The graph of y equals g of x is the image of f of x after a bunch of transformations. So there could be stretches, compressions, and translations, a whole bunch of things that happen. Corresponding points are labeled. Write, then verify an equation. So again, we're sort of working backwards to try and figure out what happened. If we look at point A on the red graph, it's at 0, 8. And point B on the red graph is at 2, negative 8. Now, a bunch of things may have happened, but it tells us that A ends up at negative 2, 0, and B ends up at 0, negative 8. And you have to find out what's happened. Now, when we did a similar question in the last section, there was only one set of arrows. So if there's only one set of arrows, usually you can just look at it and see the mental map. But when there's two sets of arrows, sometimes it takes a long time to find that what's actually happening. You might try mental math for a while, and nothing seems to work. And then I could make a question where I could be like, oh, you want to just try mental math? All right, well, I'm going to start with nice numbers, end with nice numbers, and in between I'll be nasty. I'm going to use all sorts of fractions and decimal places, and how would you figure it out then? So this is where that second strategy that we introduced is super helpful. What we're going to start is we are going to compare horizontal distances. On our red graph, if you went from A to B, how much would you go horizontally? You would go over 2 units. So I'm going to put a plus 2 because we went 2 units to the right. And if I go from A prime on the blue graph to B prime on the blue graph, I also go over 2 units. This is telling us basically your x gets multiplied by 1, which means there is no stretch or compression for x on this graph. I will also compare the vertical distances. So again, on my red graph, if I look at starting at A and going to B, can you see that I'd be going down? I'd go down 8 there and down 8 again. So I'll write that as minus 16. I've gone down 16 units. But if I look at A prime to B prime, I go from 0 down to 8. Now I'm only going down 8. To go from minus 16 to minus 8, that means our y values had to have been cut in half. What that just did is it allowed you, and you wouldn't have to write the x by 1. I'm going to just do it just because we figured it out. Our x values aren't changing, but our y values are getting cut in half. If we had done that, that would change our first points to 0, 4, and our second point to 2, negative 4. And once you have that second point, now I think you can do the mental math. For example, with the x's, if you went from 0 to 2, 0 to negative 2, would you go left or right? 2 to the left. And then double check, does that work from the second point? Going from 2 to 0, is it also 2 to the left? Yes. Well, what about from 4 down to 0? That's going to be 4 down. Check. Does that work for -4? Yes. So you could have been guessing and checking for a lot of things, and that might have taken quite a bit of time. This will let you systematically figure it out. And then, once you've systematically figured that out, we can now write the equation. We want to write the equation that says, in terms of f. So we got y equals. We're going to have f on the right. Our only stretch is y by half. That's going to be outside your function, f. Then you're moving horizontally 2 to the left. X's are liars, so that'll be x plus 2. And finally, down 4, that'll be -4. The question says, write, then verify. The very nice thing about this strategy is the strategy itself is also the verification. You've already checked that it works. We already know that the 2 points that we looked at, if we do those transformations, they get to the points we want. So the verification is built in. Do we have to do domain and range? Not this time. Just question number 9, the circle for practice.